This is lesson 5.4, equilateral and isosceles triangles. So we're going to start with an isosceles triangle. The sides that are congruent on an isosceles triangle, because we know by definition isosceles means two or more congruent sides, those are called the legs. And the angle for two legs meet, if I look at two legs, I point to an angle, I point to an angle here, that would be called the vertex angle. The side that's not a leg is called the base, and then the two angles on that are called the base angles. So we have something called the base angles theorem, and it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent, or if two sides of a triangle are congruent, the base angles are congruent. So if I knew AB and BC were congruent, then I automatically know angle 2 and angle 3 are congruent. And the converse of the base angles theorem is if I start out by knowing that the base angles are congruent, angle 2 is congruent to angle 3, then I can say that the two sides are congruent. So let's use the base angle theorem and its converse. If I knew that segment HG was congruent to segment HK, these are my legs, making this last side my base. So the two angles on the base would be congruent, so that's angle G. And the other one I can't call K because there's a lot happening in K, but angle HKG. And then the second part, I'm starting out by knowing that angle KHJ, this angle over here, is congruent to angle KJH, this angle over here. So these two angles are my base angles, making HJ my base. That makes HK congruent to JK. So you go ahead and try the next one. We are given that segment DE is congruent to segment DF. Name two congruent angles in this picture. Pause when you're ready to see the answer. All right, so we see that angle E would be congruent to angle F because those are the base angles. For equilateral triangles, so equilateral triangles, if it is equilateral, it is also equiangular and vice versa. So if I know all three angles are the same, that automatically makes all three sides the same. If I know all three sides are the same, I automatically know all three angles are the same. All right, so let's look at the first one here. We are shown that these three sides are all congruent, making it equilateral, which means it's also equiangular. So each angle has to be congruent. So if I did 180 divided by 3, we get 60 for each. The measure of angle P, measure of angle Q, and the measure of angle R each equal 60 degrees. All right, down here, I see these two sides are congruent, making it isosceles. So this JL is the base, meaning both of these are the same. They are my base angles, so that is 68 degrees as well. So we can say angle J is 68 degrees. Now for angle K, I know the 3 add to 180, so I could use 68 plus 68 plus angle K equals 180. So we get 136. K plus 136 is 180, and if I subtract that, we get 44 degrees. For our third one here, I know that's 60 and that's 60, meaning the last angle also has to be 60, meaning it's equiangular. So then it's equilateral. So I can mark all three sides congruent, and now these two sides are the same. So we're going to have 11x minus 89 equals 7x plus 19. Subtract 7x, add 89. And if I divide by 4, x is 27. So you're going to try these 4, pause, and when you're ready to see the answer, hit play. All right, so for the first one, because we knew that it was the base angles were congruent, I knew it was isosceles, so 4x plus 23 would be 10x minus 1, so we get x is 4. Number 2, it's also isosceles. They would mark the sides congruent, so I know both of those angles are the same. They're my base angles. They're both 9x minus 25. So the way I did this is I took all three angles and set it equal to 180 and got x is 7. What I also could have done is if this vertex angle is 104, if I did 180 minus 104, I get 76, and if I cut that in half because of the same, each one was 38. So I could have set one angle equal to 38. Number 3, I was marked that all 3 sides are congruent, so it's equilateral, which means it's also equiangular, so each angle is 60. So then 4x plus 8 was equal to 60. And in number 4, I'm again isosceles because these are marked the same. So if that's 29, that's 29. So the vertex angle, 11x minus 65, plus 29 plus 29 equals 180. We get x is 17. What I could have done here is taken the two 29s, taken them away from 180, and I would have gotten 122 for this angle on its own. And I could have done 11x minus 65 equals 122. All right, so here I'm given a lot of angles marked the same. So in this triangle, if all 3 of these angles are marked the same, then all 3 of these sides are the same. And if angles M and LNM are congruent, those are base angles, which means LN would be the same as LM. So all of these sides are exactly the same. So they're all 4. So I could say that x plus 1 equals 4, and get x is 3, and y just equals 4. So you're going to go ahead, try this last one. Pause. When you're ready to see the answer, hit play. So here, we knew all 3 of these angles were the same, so all 3 sides are the same, which means if this side is 28, this side's 28, this side's 28, so 4y equals 28. Also, if all these are 60, the angle adjacent to the 60 is 120 because they make a linear pair. And now the 2x, 2x, and 120. I know this is 2x because if this was 28 and this is 28, they're the same. So that's isosceles, 2x, 2x, and 120 equals 180, x. And that is the end of section 5.4.